Okay, part 2. Talk about the roots. Okay, a root is a number that when multiplied by itself, a specified number of times produces a given number. Well, that's just terrible. It's not a math book, obviously. By a specified number of times produces a given number. Which is to say, a number that when multiplied by itself, so we can take 2, multiplied by itself 2, a specified number of times, so that's one time, is going to equal 4, right? So the root then of 4, which is the square root of 4, is equal to 2, which is what they're trying to say, but a very difficult way of saying it. So this thing is called a radical sign. A radical sign. So square root. So the square root then of a number is whatever number it was multiplied by itself produced that. So what number times itself produced 25? 5. Because you just know that, right? Because 5 squared equals 25. And you knew that. So that is the square root, which is 2, right? So 2 squared is 2 times 2, or square root there. And we can also have cubed roots. So we can have a cube root, which is, you have the little 3 right there. So the cube root of 125 is
5.
And that's 5, because it's 5 times 5 times 5. Well, that was easy, because 5s are easy, but how can I do that on my calculator? So on this particular one, you have right here in the blue, you have the square root, and above that, the cubed root. Now, a little bit ago, I told you I never used the square function on here. I always want to use the same key, because all you use the square there. But for some unknown reason, when I do square roots, that is the exception to that rule for me. I mean, you do whatever you want, I don't care. But when I'm doing a square root, I will definitely use the square root function. When I do cube root, I definitely do the cube root function. Don't know why, that's just the way I do it. So if I want to know the cubed root of 125, I'm going to put 3 second, and then this button right here with the little X symbol. So
is there a cube root button for that?
Yeah, it's kind of. Oh, cube root button?
Yeah,
it's right here.
Does it actually have cube? No, it's not cube.
Yeah,
Is
it's the second to the O.
Second to the O.
0.
You use the second
Right there.
calculation.
I think that's a 0. No. Right there. So they do have the cube root there.
I knew that.
So, and then let me see, where would be like, if you want to enter in your own. I haven't used this calculator in forever. Right there. The OFF button. I don't know what that function that is. Okay, so it's the official. It's what? I don't know what that is.
You don't want to know. You don't want to know.
Generous.
Sure you don't.
I do like Top Gear, which some cars have that on there. Especially off. It's like the traction control. Okay, so back to this. So cubed root, so I'm going to hit 3, then second, and then the house button. I was trying not to say that. 1, 2, 5 equals, and it's going to give me 5.
Isn't that little house button that you refer to? Isn't that like a Greek word for that or something like that what it's actually be called?
Probably.
My teacher said it's like a carrot or something.
I know a lot of people call it the carrot. And where you also see that is like if you do a lot of stuff in Excel, that's how you do powers in Excel. On the keyboard, you use the, there's a key that looks very similar to that, if I'm not mistaken. Where is that key?
Above 6.
Yeah.
Thank you, buff 6, yeah. So I think they call it a carrot. Do you call it a carrot?
Yeah.
Doesn't look like a carrot.
I know. It's not even orange.
I call it square.
Okay. I don't think we need to do fractional powers. Okay. There is such thing as fractional powers, but I don't think that shows up anywhere on the FAA test. Let's do it for fun. 4 to the 1/2 power is the same as square root of 4, which is 2, or 25 to the 1/2 power. Can you do that on your calculator? You should be able to. 25 to the 0.5 equals, yeah, it'll do it, equals 5. So you can do that, half powers. Okay. On to something we do need to know.
You can also use the ABC instead of converting it to a decimal.
In what way?
If you're doing to the half power.
Oh, okay, yeah, instead of half. That's cool. Okay, let's talk about scientific notation. We are going to spend a lot of time working with scientific notation. It is not one of those things that you can just kind of say, well, I'm glad I got through scientific notation. You kind of have to live with it in this class, so you have to get used to it. So that is number shorthand. Shorthand used to express very large or very small numbers. Okay, the number has two parts. The number has two parts. There we go. Number has two parts. We have the first part, we have the base number. I'll call it the base. The base number, which is greater than or equal to 1 and less than 10. So the base number has to be equal to or greater than. It's got to be 1. Can't be less than 1. It's got to be 1. And it has to be less than 10. So it could be 1 up to including 9.9999 repeating. So it's got to be somewhere between those two numbers, this base number. If it's outside of those, technically it's incorrect. Okay. The second part is a power of 10. The second part is a power of 10, as in like 10 to the power of 6 or something like that. So when we put it together, we always have to have a number between 1 and 9.9999, up to and including, I should say. So 2.35, what was I? Times 10 to the power of 6. All right, so that is 2.35 times 10. 1, 2, 3, 4, 5, 6. If I did that right. 1, 2, 3, 1, 2, 3. Yes, which is 2, 3, 5, 0, 0, 0, 0. Now that's easy enough to understand. Where we start running into problems is going back and forth between the big numbers and little numbers and negatives and positives. So I kind of have a way of saying that. So let me see. Now we can do this one just for an example since it's here. The speed of light is, according to whatever I picked this up from, 670,616,629 miles per hour. Oh, I remember I got this. I had somebody stand down there with a flashlight, and I said, go, and they hit the button, and I timed how long it took for me to see the light. I divided it by the length of the hallway, and I came up with this number. What is this in scientific notation? Whatever you say, you should be 6.7. 6.7. Okay, we're going to round to just 6.7. What will be the next number? If I want to start. 1. Okay, 6.71 times 10 to the 8. Okay. 1, 2, 3, 4, 5, 6, 7, 8. 10 to the 8. Now I want you to just notice this. And again, it's real easy to look at this. Go, I got it. But it's going to get confusing a little bit because we were talking about negative powers. So I want you to look at this number right here, this 6.71 times 10 to the 8th. And just think about, and I call it unpacking. If I want to unpack this number, what I mean by that is turning it back into its other number, 670, 616, 629. I want to unpack it. So when I just look at this right here and I see that positive 8, is this number going to get bigger or smaller?
Bigger.
Okay, so keep that in mind. So when it's the positive exponent over here, your base number, when you unpack it, has to get bigger. Okay, because small numbers then use negatives, and we're going to use more negative exponents than we are positive in this class. Because we use milliamps so much, and well, it's mostly in milliamps. Okay, so small numbers use negative powers. All right, so 2.35 times 10 to the negative 6th. So I have that number, and I've just written it down. Now we got to just go back to what I talked about a minute ago. We are going to unpack this number. I have to unpack it. Is this number, this 2.35, is it going to get bigger or smaller?
Smaller.
Okay, so right, we're unpacking. It's going to get smaller. So if that's the case, then I'm going to write that number down, 2.35. And to unpack it, it's going to get smaller. So I got to add a whole bunch of zeros this way to figure out what to do, right? Because if I added the other side, it's going to get way bigger. So then I'm just going to count. 1, 2, 3, 4, 5, 6, 7, 8. And that's it right there. Okay, so I've unpacked it. Oh, I was thinking 8, sorry. No wonder you guys are all messed up. That's easy enough to fix. Look at that. Through the magic of, provided I counted right. Okay, yes.
So essentially an easier way, I guess, with me, would, so since it's the negative 6 and it's the points on the 2, would you just add 5 zeros, right? So
Nope.
you know it's going to be 6.
Nope. I don't do that.
So
I write out my zeros and I count.
Okay.
Because
That's a trick that I use actually with negative numbers because it's always.
Because you know you're going to
Yeah.
move it one
place,
space.
So you just.
okay, so like Eric said,
That would work.
you can just hop it too. I honestly tend to do that more. You guys will see that, but it's like I would say 2.35. I would just go 1, 2, 3, 4, 5, 6, and then I fill it in as I go. So either way, it's the same thing. But the thing I need you to remember is we're unpacking it. Yes, if your brain works, I don't care how you do it. But what I don't want to do is come up with this, all you have to do is remember the shortcut. If you subtract this from that and move it, since it's negative 6, really only just do it 5 times. No, don't do that. Because there's somebody in here who's going to go, well, no, I had it for a minute and now I just lost it. So I want to keep it very simple. You can do it your way if you like. I'm not going to keep you from doing it. Okay, so small numbers. Okay. So in much the same way, when we go, of course, the other way, which is now just sort of repeating what we just learned, convert 1, 2, 4, 0, 1, 2, 3, 1, 2, 3, 1, 2, 3. I left the spaces there so you can see it easier. To scientific notation, what is my base number? 1.24. I would not round. I would not. It's not that hard to write three numbers. So sometimes people go, well, should I round the 1.24? If you really, you could have wrote the 4 in the time it took you to ask that question. So no, it's only three numbers. If it's really that difficult, then I don't know. Take an aspirin and just deal with it. So 1.24 times 10 to the, is this going to be a positive or negative number? Positive, because when we unpack it, it's got to get much, much larger. So times 10 to the what? 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Oh, you guys are so fast. Times 10 to the 12. Okay. Why is it in red? I don't know. Let's see. 0.1, 2, 3, 4, 5, 6, 7, 4, 5, 7 equals, what's my base number? 4.57. Well, how about 45.7? Can I do that? No, I can't, because it's got to be a number between 1 and 9, which means you have one number over here. Can I put 0.457 times 10 to the? No, because it's got to be between 1 and 9. Okay, you got to have one number on this side of the decimal and however many you want to do on the other side. Times 10 to the 1, 2, 3, 4, 5, 6, 7, 8 times 10 to the negative 8, because when I unpack it, the number is going to get very, very small. Okay. So at one point, my notes go so deep. I've learned since not to do this. But I talked about to add and subtract powers such as 3.20 times 10 to the 5 plus 5.1 times 10 to the 5. You can add that because the 5s match. So you can add the numbers and carry the power. So you really could just add 3.2 to 5.1, which would be 8.3, and then carry the power times 10 to the 5. So if you had something that was mismatched, like, well, here's my example. If you had 3.20 times 10 to the 5, and then you wanted to add 5.1 times 10 to the 4th, you can't do it that way. You actually have to change this one to 10 to the 5th or this one to 10 to the 4th. But you can just use your calculator. Just make sure that, and it doesn't matter then what this symbol is, you can do addition, subtraction, multiplication, division. Just make sure that you are putting it in parentheses as it is written. So in your calculator, you put parentheses 3.2. And to do the x at 10 to the 5, I use the EE function on the calculator.
Really?
What does that do?
You have to log?
I do not use log now.
Second log with the 10?
Yeah, second. No, I use the EE function.
Let's go right over x to the negative first power.
Hang on.
What does E do?
That is the exponent. EE literally means it's the 10 to the. Okay, so you have the EE function right here. It's right over. Okay, now pay attention to this one, because this is going to really matter. Want me to wait? Okay.
Are you expecting something to change on your screen on the calculator up there?
I wish it did. I look so hard.
Every time you press them, I'm like,
Yeah.
You should really get sponsored by this calculator. Your lectures should just be using.
They do have a calculator that I can actually use on screen like
I
this.
thought you used that one time.
I did for a short period of time, but I had to pay a lot of money for it, and you had to buy the calculator, which is really expensive. They don't do it with the cheap ones. Okay, so here's your EE key, which is 10 to the whatever power. Here's your EE key here on this one. Okay, so in a little bit, and when we get into electricity a lot, we are going to be using this 1/x key, 1 over x, for you guys on this one. And for you over here, it's x minus 1. but I tend to say 1 over x is how I will say it. I will say that number times 1 over x. You guys have to know, if you're using the blue one, that it's actually x minus 1. That is the same thing. So x minus 1 is the same as 1 divided by x. So 1 over x, x minus 1, same thing. I will say EE, which is EE here, and it's EE there. I think that's why I like this one, because it's just out there in the open. So I don't use the 10x key. I'm not entirely sure if that's the same one. But I use the EE.
It works. Times fine using math.
Is it the same?
Yeah.
Okay. But I don't know. I use EE, so that's just the way I do it. You can, if you want to do it differently, you may do it differently. Only thing I ask is don't do it differently and then yell at me because you got the wrong answer.
So do you just enter the number like 3.20 and then hit the EE and then 5?
Yes. So this one I would do. Let me go to a pen. Okay. So I would, let's do this one. So parentheses, literally the parentheses, 3.2 second EE, and then the 5, and then close parentheses, plus open parentheses, 5.1 second key EE, then 4, then close parentheses, then equals. And hopefully you get the right answer. So tell me what you get. Oh, this would be interesting.
375,000.
Oops, say it slower, Hannah.
371,000.
371,000. Okay, so let's say I want this in scientific notation. Now you guys are all smart enough that you could probably, faster than you can convert your calculator, just count it. 1, 2, 3, 4, 5. So it's 3.71 times 10 to the 5th. But while we have that number in there, 371, 1, 2, 3, we could hit second science engineering, bump it over to scientific, hit equal. No, that didn't work. Probably because I just typed in the number.
Mine works.
Yeah, because I typed in my number and I didn't know I was wanting to do it something yet.
Can you do it on the other one?
On that guy?
Yeah.
Oh, the scientific flow? Yes, there's a way to do it. I just don't remember how to change it offhand. It wasn't that easy. I think it's in the lid. If you pull the lid out, the little cover, it tells you how to do it. And it might be that degree button. Hit the second degree.
Is it just a second 5?
Yes, that's scientific display format.
Second, is it second degree?
No, second 5.
Yes, you're right.
Hang
It
on.
is second
Which one?
and then psi and it'll be.
Second pi?
5.
Oh, second 5. Oh, there it is. Thank you. Scientific, second 5. Second 5, second 4 is flow, second 6. Thank you. I just didn't see it. So, okay. So, given that, now we can do anything and manipulate all of these scientific notations. But the thing that you have to remember is this unpacking, because I see so many people. I always feel bad when you make this mistake. It's like it was to the negative power, and then you made it much bigger. 2.71 times 10 to the negative 6, and now I have this gigantic number with all these commas. I'm like, well, no, it's a negative 6. It's a very small number. Okay, so along this line, so we have these powers, and with these powers,
Great responsibility.
I know, so that's why I was stumbling, because I'm like, I didn't want to say that, but thank you for saying it for me. We give them names now. So instead of just saying, 10 to the negative power of negative 3, we're going to give it a name. So there are a lot of them, and I'll give them to you, and then I'll tell you which ones to memorize. So we have tera, which is 10 to the power of 12. Giga,
What are these called?
10 to the, what do you call them?
Prefixes?
Yeah, that's what I call them. Mega, make something great again. What is that?
One separate or one different letter.
Make everything.
Make everything great again. Thank you. Tera, giga, mega, kilo. Oh, I should put the thing. Okay, hang on. Kilo is 10 to the third. Okay, so tera, the prefix then is a big T. This is a big G, a big M. And this is confusing because this is a little k.
Those are the prefixes.
Yes, the prefixes. Kilo, hecto, H-E-C-T, hecto, 10 to the second, and hecto is a little h. Deca, 10 to the 1, and that is dA, little dA, and deci, which is 10 to the negative 1, which is d, deci, centi, 10 to the negative 2, that is a little c, and we get milli, M-I-L-L-I, 10 to the negative 3, which is a little m, micro, 10 to the negative 6. Okay, this is like a cursive U, where it's actually a Greek letter, which is mu. Mu. So why that one just became Greek, I don't know, but that one just is. I'll go over here so we can see it. Nano. Nano.
Is that supposed to be a negative 3?
It is.
Yeah. 10 to the negative 9. N. And pico. 10 to the negative. Yeah, it's pico. That's where it came from. Pico de gallo, which means very small gallo. And that is a lowercase p. Okay, so you have to memorize all of them. Just kidding. Okay, so if you're going to memorize something, I would absolutely positively memorize that one, that one, that one, and that one. And you could throw in this one if you wanted to, mega, but we're not going to use mega around here. But it wouldn't. But those are your functions that you're going to use in electricity. And most of the time we're going to be using these two right here. And the one that you will use the absolute most is this one right here. Milli.
No, Miller.
Yeah. But you need to know your millis and your micros.
So mega is a capital M?
Okay, so mega is a capital M. Kilo, so this is weird. So hecto, yeah, it goes capital, 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 not capital. And that bugs me. Why is it not? And according to what I read, which probably wasn't Wikipedia because I don't use Wikipedia, but I found somewhere that the reason why they use a small is because a big K is for Kelvin.
Yes.
Glad you agree. So it's a small K. So if you see me using a big K like on something that's printed, it meant kilo. Okay. You cannot do something like this, like 3.2 times 10 to the negative third millis. Okay, because that is a lot. That is mixing things up. So what is 3.2 times 10 to the third? 1, 2, 3. So that's 0.0032 millis. Millis is 10 to the negative 3. So it's 1, 2, 3. So it's 1, 2, 3, 4, 5, 3, 2. So if you said 3.2 times 10 to the third millis, that is 0.000032, which is 1, 2, 3, 4, 5, 6, which would be 3.2 micros. Hopefully I didn't confuse you. My point is, don't mix up this and this. They don't belong together. They're two separate things. Either use a power of 10 to the whatever power, or use one of the prefixes. Don't combine them.
So the correct way to say that would be 3.2 milli.
Yes.
Okay.
And so when we're doing electricity, we're talking about stuff, and it's 50 milliamps. don't tell me it's 50 times 10 to the negative 3 amps. Please say milli. Or micro, as it would be. Okay. You got all that? So where would you see some of this kind of stuff? Or what would it look like? So we can have 780 kilowatts. That would be kilowatts. And generally speaking, if you don't, I'll never bust you on this, like, oh, you used a little k or a big K where you shouldn't. If you wrote a K and I can understand you, then I'm pretty lenient on that stuff. But generally speaking, it's a capital if we're talking about somebody it was named after. So it's a kilowatt. Watt is a person, so it gets capitalized most of the time. So 780 kilowatts. How many watts is that?
0.78 watts.
780,000 watts.
Okay, K is 10 to the positive 3, so it's 780 watts. All right. 12,524. Let's say watts. How many is that in kilowatts? 12.524 kilowatts. Very good. 0.005 amps. How many? What is that? Okay, very good. 5 milliamps. This is just practice right now. You guys will get it. If you're like falling behind a little bit, that's okay. So what is 800 milliamps? If I want to know that one in amps, so I've given it to you. How many amps is that? Okay, 1, 2, 3. That's 0.8 of an amp. 0.8 of an amp. All right. If I have 5, what is that? Microamps. How many amps is that?
0.00000.
Okay, so I'm going to move it over 6 places. So that'll be 5 zeros. 1, 2, 3, 4, 5 amps. We don't usually see that in amps. Where you're going to see that is, well, it's on here, picofarads. 10 mega ohms. This is a symbol for ohm. Unless you're my daughter, then it's the symbol for Lululemons. So you have 10 Lululemons. How many is that in ohms? What? Did I lose everybody?
0.01.
Wait, Wendy's got it?
10 million ohms.
10 million ohms. So 10, 1, 2, 3, 4, 5, 6 ohms. Did you have to convert it to Lululemons and then to ohms? Or you're good just going right to ohms? Do you not know? Everybody knows what Lululemon is, right?
No.
The girls do.
If you don't know what Lululemon is, that means that you're not overpaying for your clothes.
Easier to sing than doing it.
Okay. 125 picofarads. A farad is a measurement of capacitance. So picofarads is how many farads? Yeah, I like that. What'd you say it again?
1.25 times 10 to the negative 12 farads.
It wouldn't be to the 12 because
Negative
it wouldn't be to the negative 12 because pico.
Fine.
You know, she's right about there. So pico means 10 to the negative 12, but we move the decimal places over 2 to the left, so already. So it'll be, yeah, to 10, negative 10. Or 1, 2, oops, I got it this way. 1, 2, 5.
9 zeros.
And 9 zeros? Okay, I'm going to trust her. Because 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9. Trust but verify. Okay. We're moving right along. You guys doing okay? We are going to do a lot of algebra. You guys are going to do great because we do it together. I really don't want you to be, I talk a lot about when we get into, especially AC, when we do these algebraic problems and stuff. We do them together, and we work them together. And it's almost like you don't even have to unfortunately, you don't have to know what you're doing. It's like I just see a whole bunch of math on the board. I will do math. I get to the end. I'm like, the answer is 12. I'm like, you did it! And like, I don't know what the hell 12 was. But okay, so algebra. Remember, so we talk about some rules. Whatever you do to one side of the equation you must, you don't have to, but it doesn't work if you don't, must do to the other. Do to the other side. So, like for example, we've done a whole bunch of this. We had 5x equals 45, and we want to isolate the x. We're going to divide that by 5, so we have to do it to both sides, and that cancels that out. So x equals 45 over 5, and 45 divided by 5 should be 9. Okay. If we have x plus 18 equals 60, how do we isolate the x on this side?
Subtract 18.
Okay, we take away 18 from this side. Well, now this side, what do we do?
Subtract 18.
Take away 18 from that side. Okay, so it's x equals 60 minus 18 is?
42.
Thank you, 42. I love it when I hear that kind of. Okay. We have some number minus 22 equals 100. Now I know when I was in grade school, I would have just figured out, oh shoot, I would start counting 1, no, 2, no, 3, no. I'm still working on my problem. So how do we figure this one out? Okay, we're going to add 22 to both sides. So n equals 122. Okay. If I have n divided by 5 equals 50, what do I want to do? Okay, so if it's divided by 5, what's the opposite of divided? Okay, multiply by 5. That's the multiply sign. We can do that. Times 5. So that cancels it out. So that number equals 250. Okay. Okay, I got a quick test for you. Your entire future as an aviation mechanic rides upon this.
Oh, wow.
What fastest will I graduate?
I will. Yeah. Okay, this is an important test. I got it right off of Facebook. 40 plus 40 times 0 plus 1 equals. $41? 41. How about 1?
What?
Well, 40 plus 40 is 80 times 0 is 0 plus 1 is 1.
Oh.
Okay, so that's wrong. So we do not do left to right, right? So I'm hearing it. It's please excuse my dear Aunt Sally, PEMDAS. Now I like to write it like this because some people write it like this. Please excuse my dear Aunt Sally. And so this is parentheses, exponents, E-X-P-O-N-E-N-T, exponents, multiplication, division, addition and subtraction. And if you write it like this, to me that looks like that is the order that you should do things in. First parentheses, then exponents, then multiplication, then division, then addition, then subtraction. But that is not correct. It is actually parentheses first, then the exponents or radical sign, then multiplication, division from left to right, and addition, subtraction from left to right. So you don't actually put addition over, you work it from left to right. So I think that makes a big difference. And then how about, what if we said 48 divided by 2, 9 plus 3. So what would that be? 2? You're fast, man, you're fast on that. Just not accurate. 28? 288? Okay, well, when we look at this, what's the first thing we do? Parentheses. So 9 plus 3 is 12. Well, it's still in the parentheses. 48 divided by 2. So this parentheses means what? It means multiply. So we'll just do it from left to right, since I don't think it's going to matter. So 48 divided by 2 is 24 times 12. 288. Okay. So just remember that. Please. Somebody else had another thing. I feel like it was you. Did you have some other?
I don't think it's.
All right. Probably not. All right. So order counts. And then when it comes to brackets, also remember that the first order bracket is actually this. So these are done first. Then these brackets. So these are first.
Wait, I thought you saw
Yeah.
These are second.
saw
No,
the
other way,
inside.
no. Other way around.
Isn't it the other way around? Because the brackets are going to go around.
Yeah, the big
parentheses,
ones go
parentheses
around
would
the-
be inside.
Yeah,
The box ones go on the outside of the round ones.
yeah,
You guys want to debate this for a while?
yeah. Just Google it, you know.
Yeah. It's time to pick up YouTube.
Because they're thinking of problems with the parentheses inside the brackets, but if you have parentheses besides the brackets go first.
Say that again.
There was a problem on there.
So,
I had-
like, they're thinking of problems where the parentheses are inside the brackets, but if
I
you have a
think so.
problem where the brackets are besides the parentheses, like outside of it, then the brackets go first.
So if I wrote it correctly,
My calculator also got the answer 2.
okay.
So
Of what?
for that question that you just did.
You
Because
gotta
there's
you gotta multiply and then divide.
Yeah, I think you gotta multiply because it's still technically like in the parentheses.
24 is 2.
I always thought addition and subtraction was left to right.
Yeah. Well,
288.
oh, did you leave it in the parentheses?
So I put it in just like that. 48 divided by 2 parentheses 9 plus 3.
Oh.
I got 288.
You got 288.
Yeah.
Dude, is my calculator defective?
I do know that I'm right. Okay. So this would be the proper way to write this if you're done trying to debate this.
I don't have brackets on my calculator.
9 divided by 3?
Yep. Okay. So, I think I know what you're. Yeah, I guess I kind of. I shouldn't have said first. It's larger is what I meant. Larger grouping and smaller. That'd be a much better way of saying it.
That makes sense.
Yeah, sorry. I'm like, what? No, I know what I'm talking about. Okay, so I was thinking like first order, second order, but not in order. Okay, so where would we start with this one?
Inside of the brackets.
Okay, inside the brackets, but which part inside the bracket?
Parentheses. 9
Which-
divided by 3.
Okay, so it really wouldn't matter if I do this here or this here first, because we're not going to do anything with it. So 9 divided by 3 is
3.
3 plus
7 squared.
7 squared is correct. 7 squared. So let's bring that down again. So it's 3 plus 49. All right, and that's, we could kind of still leave that in brackets, because over here is 2 times that. So we've got to still complete what's inside the parentheses, which is
52.
52. So it's 2 times 52. So we have
26.
26.
104.
104.
Excuse me.
All right.
Divided in 2.
Okay. Well, that was a good place to get to for tonight. That was a whole lot of stuff. But I want to try and be in front of you guys as much as I can for those having trouble in math. So, all right. Well, do me a favor. Don't go away mad.